Alright, so we're back with the third video, and I'm pretty excited about this one because I think this is where things get cool and we start seeing the payoff of the 3D projection, the pseudo 3D world, because we're going to start moving through it. So we're going to start using this handle input method. I also want to say, up until this point, if you're having trouble understanding what I did in the last video, make sure that you read that other article I linked to. Also, maybe look at the code a few times. If the particular math stuff is confusing you, you can always Google cosine, sine, those things. That's some basic, just right triangle trigonometry stuff. You should be able to find some very good information about that online, much better than I could probably give you in one of these videos. Anyways, we're going to get right into this. So, in the handle input method that we made before, first we're going to pass this float delta into it. Now, man, thinking about three things at once again. Okay, that should go down here. Cool, so we're going to pass this float delta into it, and I'll tell you why in a moment. So what is this float delta, first of all? Well, it's basically the time between frames, and what this is going to help us do is we're going to multiply our movement by this value in order to get a consistent frame rate on all machines. So here I'll show you. This is how you do sort of keyboard input in Libgdx. We can do it through if statements. So GDX, we're just accessing one of the GDX libraries there, dot input. And then we have a couple of different things: button pressed, key just pressed, is key pressed. So I believe is key just pressed. If you press and hold the key, it will not continue to do anything. Whereas is key pressed, if you do that one, if you press and hold the key, it'll continue to read the input until you let go of the key, rather than with the other one, if you just hit the key and hold it, it'll only happen once. It doesn't read the subsequent keys until you've lifted your finger and put it back down again. But for movement, we definitely want is key pressed. We want it to read it all the time. And then I believe it is input dot keys. Yep. And then we're going to say up because we're moving forward. Now, if you remember from last time, this is what we got. We got the start of our world. This is cool. And so what we need to do is we need to access our position. So we're going to pixmap.pause.x. Now, this is typically probably bad practice to just, in Java, to just make these public and then access them directly like that, rather than through getters and setters. And in a full game, you'd probably not even want to have them in this class at all. You'd probably make some sort of player or world camera class yourself that you would put these in, and then you would access them through that. But for this tutorial, like I said, we're not going to make a full game. We may do it later, but initially I just want to get through some of the stuff to show you guys like proof of concept, right? That this stuff really does work. Now, every single time we press and hold down the key, we're going to add some sort of value. In this case, we can just say 1 for now, and we'll skip doing the delta for now. And then we're going to multiply that by our... Actually, first, let's just see what happens if we don't, right? Let's just see what happens if we increase our x value. Oof, it's kind of weird, huh? Let's see what happens if we increase our both x and y to indicate that we're moving totally forward on this plane. Once again, like I said, if we press and hold the key, it's going to read that the up key was pressed every frame, and it's going to do exactly what we're doing here. It's going to add 1 to the x and y values of the position, effectively moving you through the world. And then see when it comes down here and it reads the position, it's going to say, okay, he's moving through the world, so we're going to change where we're sampling from the texture, right? Every frame these numbers are going to change, because if you're moving. If you're not, they're going to stay the same, so it's always going to sample the same place, right? But since we will be moving, it's going to keep changing. Cool. All right. So if we do both, still kind of weird. That's because we need our good friends cosine and sine again. Now in here we have to put pixmap.angle. Just like last time, we're just putting our angle in there because we need to take into account, since this is our theoretical position, not on the screen, but in the world, we have to take into account our theoretical angle in the world too, to get movement, right? Now, if it confuses you when I say theoretical, once again, I just mean the fact that we have, okay, actually it's not going to play right now. Let me do this first. This grass tile here, or we as the camera have sort of, or this grass tile has a position in the screen, right? But it also has a position in the world, just as we do. And once we put a player in, that'll be more apparent because our player will be like right here, right? And then he'll have a position on the screen and a position in the theoretical world. But we're going to be moving him in the theoretical world, not on the screen. He's not moving up and down the screen, right? He's moving in the world. So we need to take into account his supposed angle in this world. Anyways, with this new movement technology here that we've just built, let's go ahead and boom, now we move smoothly. This is cool, right? We move smoothly through the world, and it really looks like we're moving through a world. Now, we can move to, we can sort of rotate also. We're just going to add another part to this statement here. 1 second. Cool. So GDX. I usually write these out ahead of time and keep the code on my other screen, because the thing is I want to minimize the amount of times that I mess up, so that way we don't waste time in the video, right? Not that I would mess up too much, but there's always the risk when you're recording. You can just waste a lot of time. So anyways, this is where it gets a little bit interesting. So what if we wanted to sort of strafe in the world, move side to side, right? Well, we're going to do the same thing. We do not want arc cosine, though interesting enough that a cosine, we will be using arc cosine later for some stuff, and that's going to be really, really cool. So what we need here, now I bet you're saying like, okay, so strafing, which if no one knows what strafing is, it's kind of like what you do in a first-person shooter or something. When you move side to side, you can move forward, backward, side to side, and you can also rotate. This is going to be the side-to-side code. So when we hit left, we want to rotate left, right? So this code looks the same, and it is the same, but we're about to do something to it. That's not what I wanted. I wanted to copy that so I didn't have to type it out again. Well, we're about to do something to it that's going to make it different, right? So we have our normal angle, but we want to move at a 90-degree angle to the way we're facing. So once again, this is in radians. We're just going to subtract from this, and actually, this might end up being the wrong direction. Might end up strafing. Okay, see? There we go. Now we can strafe left. So why does this work? Well, 1.5 radians is roughly equal to 90 degrees. So when you subtract sort of 90 degrees from your angle, and you also indicate that you want to move, that you want to make some sort of movement, it's basically without rotating you, it's just going to move you 90 degrees to the left, right? This is going to move you in your normal angle, which is just forward. This is going to move you 90 degrees to the left. So let's copy this code. and let's do the right strafing. This is just the way Libgdx does input, by the way. So they have a class, GDX, inside of it is, input, and then it has the ISKey press you can access, and then there's the input class, you can access the keys class, and you can get their constant, which is right, and that's how they handle it. And you can get just about any key in the keyboard this way and do whatever you want with it. Now, to move the other way, this might be obvious. Where's my plus key? There it is. We're just going to have to cool. So now we should be able to strafe right and left. Now, what if we want to rotate? Well, we're going to do that now. So first, let's go up here and make sort of, we'll make some two. Probably add a final, this will be a double actually, turn angle. Let's just call this 0.9 for now. That's T angle or whatever it is. Cool. So we're going to add this on. So how do we want to turn? Let's just use the A and D keys since we're using the arrow keys right now. So we'll do left first. It should be A. Cool. So for this one, we're going to actually do something very simple. Plus minus. Plus equals. Actually, I think this is wrong. For left, we should be doing minus because we did minus up here. Okay, minus equals. I assume everybody knows what the minus equals operator is. Just a short version of saying pixmap.angle equals pixmap.angle minus whatever. This just is all of that all in one. Oh, anyways, cool. All right, let's copy this for the right side. D. And this should work. I might be wrong. It might be the other way around, but ooh, we are rotating way too fast. That's why it looks like we're moving side to side. Okay, so, and this is once again why it's important to multiply by this delta value because every machine is different. 0.9 on some machines could be even faster than that, and on some it could be much, much slower. So, but if you multiply by the delta value, it'll give you consistent. Okay, we're still rotating really fast. Ah, that's a little bit better. Now it looks like some actual rotation. We got strafing. So you can already see how this could be used for a lot of games, right? You've already got the makings of sort of a first-person shooter type control system with the strafing and the moving forward and the rotating. And, you could actually, we should probably, let's separate the rotating from that so we can strafe and move forward and rotate and stuff at the same time. I think that would be a good idea. Cool. Now, I bet you're wondering, we need to get some more stuff. Oh, wait, actually, there's one more movement thing we want to do. We are going to fly up and down in our world a little bit. So, copy this again. What the heck? Okay. I thought I hit the right keys there. Anyways, so make this one space maybe. I like the idea of it being space at least. And this is where we're going to use the Z portion of this, right? I told you that this Z portion was the height above the ground in this little distance thing, and we're going to see that being used here. So this is going to be, we're just going to add, we'll try a value of 1 at first too, and then we'll say, for going down, we'll say, oh, whoops, this needs to be minus equals. Say 1, 2, and we'll actually, for this, we'll use the down arrow. How about that? So now when we run it, look at that, isn't that crazy? We're moving like, I know it looks so funky right now because we don't have a background, but we're like just fully moving around this world, huh? And you can set these keys however you want. Moving up, the grass gets further away. Moving down, grass gets closer. Yeah, so we have like sort of full control of what we're doing now. So let's put a track in here, and this is the really easy part. So if you go to my assets, I already have a track that I made using a sort of tile set. Just a brick. This brick was actually meant to be for roads and like grass and stuff tile set. But anyways, cool. So we're going to go ahead and put the track in there. I think the grass color on the side of the track matches pretty well. And once again, I can make these assets available to people if they want them. All the assets I'm using came from places like Open Game Art and stuff. Not really, you know, it's not like there's like a copyright on them or something. Cool. So just like before, you can use set color and draw pixel to draw to the ground in your world, right? Because you're drawing to your pixel map, which is class represents. And just like, except it's much simpler this time. So first off, we need a pixel map. Private, pix map, track, this is your track. We're going to go down here and we're going to set it just like we did the grass. Cool, and we're just using the absolute path there to our, we've set it up in the run configurations or the assets folder. So track, and we're going to get a pixel at a certain position, and we're going to set that as our pixel to be drawn on the pixel map in the screen position that we currently are. And we know what pixel we want by using where we're sampling our texture from. Space X. Right, you have to cast and zoom in. Yes, thank you for giving me parentheses where I did not want them. You know, sometimes autocomplete is amazing, and sometimes it just like gets in the way, right? All right, what are you mad about? All right, did I delete something where I shouldn't have? Yep. Cool. And we don't have to do this math.absolute value and modulus stuff because we don't want to draw our track infinitely, right? We just want to draw the track once. We don't want to sort of tile the track over and over again like we want to tile the grass. We just want to tile the track once. I suppose if you created a big enough grass texture, you wouldn't have to tile it. You could just draw it in, though it seems a little silly. Cool. And then we're going to draw text that pixel to the screen where we already know it should go because we're looping through a screen and, you know, screen X and screen Y here. I hope my explanation last time was sufficient for that. If not, like I said, read that other article or ask me in the comments questions about it. I'll try to explain it again. Let's see here. Let's see if we can find our track. Where are we in the world? Ah, I was like, are we too far away to see it? Now this is cool, right? We've come along, we're really here now. So now we've like drawn something in the world. This is really starting to actually look like a game now, right? Like if we were to have a little cart dude and we're going around the turns. This is kind of lame right now, right? Because we don't have any mechanics in it. But hey, this is starting to really look a lot more like that Super Mario Kart that we saw. And you know, obviously their screen's a little thinner because they split it here and between that and mini-map. And we might do that a little bit later, but this is cool, right? Of course, I guess we need to get a tile that actually matches our... I'm getting confused in my own controls here. But yeah, man, we're there. Cool, so I think that's what I wanted to show for this video, basically. Once again, I hope y'all... Let's just take a look at this right. Hope y'all got something out of this already. I mean, maybe some people could come up with a way to already use this basic structure for the game. Next time, I'm thinking maybe we're going to put this background in. And maybe have it scrolling and stuff. Or if I can think of something more interesting to do next time, maybe we'll do that too. Yeah, I'm not sure what we're gonna do yet. We're probably the background though, and then after that we'll get into some sort of like sprite billboarding and things like that. And that'll be another one of those really annoying videos where I have to type it all out and just have it ready ahead of time and then sort of go through it line by line because it's going to be a lot of stuff. That's like the next really big sort of mathy annoying thing. The background will be lots of fun though, and that'll probably be the next video. Cool, so see you guys next time.